Welcome everyone, it's Actuary Dude over here looking at another fun-filled question. So the force of interest delta t is equal to that. Calculate the present value of a unit sum of money due at time t equals 10. Okay, so how do we figure this one out? Well, what we really need to find is v of 10, and in order to find v of 10 we've got to find v of t for the whole function itself, for all of delta t. So what are we doing? Well, this bit over here, I'll first just try to work it out like over here. So let's see, we've got to find e to the negative integral between time 0 and time t of 0.04. Okay, so 0.04, and that's dt. Over there, it should really be ds, but that's fine. And so then all that's going to be is the integral of that is 0.04t, and that's e to the negative 0.04t. And so normally we'd be subbing in our values of t and 0. When we sub in t, we get that. When we sub in 0, it's all 0. So in fact, it is e to the negative 0.04t, and that is for 0 is less than t, which is less than or equal to 5. Okay, so now we just got to find the next bit to try and get v of 10. Actually, first I'll just find out what's v of 5, because we're going to need that in order to, I guess, get v of 10. So v of 5 is just you sub in 5 into here, so that's e to the negative 0.2 when you multiply them. E to the negative 0.2. Alright, that's always handy to know. Now let's find e to this bit. So what we're really trying to find over here is e to the negative integral between, and we're looking at time 10 is when we're getting up to, so we may as well write time 10 in there, and time 5 is where it goes as low as, and that's for our function 0.01 t squared minus t dt or ds, or, well, I mean, if we had ds then that would have to be s's over there, so that's fine, we can leave dt like that. Okay, and so now all we got to do is find the integral of this. Well, the integral is still going to be with the 0.01 on the outside, and that'll then be t cubed on 3 minus t squared on 2. There's a negative outside all of that, and that's between time 10 and time 5. So now, and there's an e over there, so if we just sub in all of these values, the 10 and the 5 into there, and then we include this bit, e to the negative 0.2, we'll then be able to find out what v10 is. So in fact, I could actually write, to simplify a few things, v of 10 equals that multiplied by e to the negative 0.2. And now let's try and get Excel out to help us on that. So we are saying that it is e, I'll just work it out like this. I'll first do the inside brackets bit. So we're going to sub in 10, so that's going to be 1,000, I'll put inside some more brackets, 1,000 divided by 3, that's minus 100 divided by 2, and then that's going to be minus this with minus this bit over here with 5 in there, so we're going to minus the whole function again. So minus 125 divided by 3 plus 25 divided by 2, and I say plus because we're doing minus there. So there we have that, and I'll put that all inside of bigger brackets and multiply it by, I'm going to say a negative 0.01. Negative 0.01, which gives us this bit over here, and now we've got to minus our 0.2, and then we can find what the exponential of that is, and this is what I guess the question is referring to. This is the present value of a unit sum of money due at time t equals 10. So v of 10 is 0.064. So I'll just note that down. That equals 0.064, and there was another 4 there, I guess depending on however many decimal you want it to go up to. Okay, so let's check out the next bit. So double I, and what did it want? Calculate the effective rate of interest over the period t equals 9 to t equals 10. Okay, so essentially we're just going to find this same integral over here, but we're pretending that we're putting some money down at t equals 9, and then it's going to accumulate to time t equals 10. So all we have to do is find e to the, and it's the positive integral because we're doing some sort of accumulation over here between time 9 and 10, and then we've got our 0.01 there, and still, well, this would be t squared, I guess, minus t dt, like that. And so then that's when we simplify this, so when we find the integral of all of that, it'll then be e to the 0.01 t cubed on 3 minus t squared on 2 between time 10 and time 9, and we can just use Excel to find out what that answer is going to be. So I'll just bring that up over here. Sorry about that, I'm just dealing with a weird sort of mouse right now. Okay, so here we go. That's then going to be, well, we can just sub in the values as we did before. So it's going to be 1000 divided by 3 minus 100 divided by 2. That'll then be minus, and this is actually going to be 9 cubed divided by 3 plus, and that'll then be 9 squared divided by 2, which is, I know that one's 81, divided by 2 there, and then close all the brackets, sorry, and then multiply it by 0.01 equals that, and then we can find the exponential of that value. Now, that all looks well and good, that's 2.244, but we know that e to the delta is equal to 1 plus I, because this is 1 plus I, so if we had $1, we multiply by this, that's how much money we'll have in the end. So what is the actual effective interest rate? It's actually this minus 1, which is 1.244. So that would then be 1.244, which is equal to 124.4% for that 1 year per annum. So that is the answer to double I, which asked for the effective rate of interest over the period 9 to 10. So now let's look at this other bit. So part 3a, in terms of t, determine an expression for v of t, the present value of a unit sum of money due during the period, this bit over here. So 0 is less than that. So what is the, I guess it's saying what is the present value? It wants to know an expression for that. Well, that's just v of t. We kind of already figured that out over here. For 0 is less than t and greater and less than or equal to 5. So you can really just write it down. If you wanted to, I guess, show some working over here, is what you would do is you would be writing this step over here and then writing this bit over here and then saying, well, here's the answer that we get. So it's almost a bit of a trick question, but I think it's probably only worth 1 mark. And then I'll just do part 3b over here, and that says calculate the present value of payment stream paid continuously for the period 0 to 5, where the rate of payment rho t at time t is equal to that. Okay, so we have the integral between 0 and 5, and this is the present value of payments. So rho t is going to be e to the 0.04 t multiplied by v of t, and v of t between that period 0 to 5 is e to the negative 0.04 t, e negative 0.04 t, and dt over there. So what happens when we multiply these together? Well, we're just going to get e to the 0, which is equal to 1. So then I'll just write this down over here. So the present value is equal to the integral between 5 and 0 of 1 dt. Okay, so when we do that, well, the integral of 1 is just t, and so putting it between 0 and 5, that's going to be 5 minus 0, which is equal to 5. So in the end, our answer is $5, pounds, whatever. That's the answer. So thanks for watching, and if you have any questions about any of this, because I think I may have rushed a bit, you can feel free to ask. So thanks a lot for watching.